Hey science guys, welcome back. Hope you had a good time between now and yesterday's video. Hope things are going well this week for you. I'm coming at you today with some more science stuff. Going to go over a couple pages. First one I'm going to look at is 246 and 247. It's a great page here talking about this term called acceleration. Now we might think we've heard the word acceleration. When we accelerate, usually we think of that meaning we go faster. But we have a definition for acceleration we're going to look at here that's going to tie in with what we talked about yesterday. Yesterday we talked about speed, and we also talked about velocity. Now the difference between speed and velocity is velocity tells a direction that we're in, okay? So keep that in mind as we go through, and as we look at this to begin, we see a definition for acceleration here that says acceleration is any change in velocity. So when our velocity changes, it's basically a change in velocity, which means it could be speed or direction. So over here, I've got acceleration is a change in velocity. And remember, velocity is speed and direction. So it could be either one of these. If any of this changes, how fast something's going or what direction it's going, we're going to have acceleration happening here, okay? So it could be something speeds up. It could be it slows down. It could be it stops and starts. It could be it turns left or turns right or goes up or down. It could go the same speed but turn a little bit. Anytime we turn, if we're running on a track, we might be going the same speed, or a car might drive and go and turn. If it stays the same speed but turns to the left, it's still accelerating in some way. So sometimes acceleration sounds like it would be a synonym for speed, and they're kind of related, but it all has to do with motion and measuring motion, but acceleration specifically is about speed and direction, any change in velocity, okay? So they give us this nice example here of like a fly flying around a room. This lady's trying to swat the fly. It might go from being still and then speeding up and going fast, accelerating, going faster and faster. It might slow down, go slower and slower. Usually when we hear acceleration, we think going fast or going faster, but acceleration happens when we actually slow down too. The speed changes by becoming less, and sometimes we might call that deceleration, but still a version of accelerating, okay? We also have turn and speed up, so it might change direction and change speed, and that of course would be two examples of acceleration, but in that case acceleration is happening. It might stop and then start again, so go to 0 speed and then up to speed after that, changing the speed. And it might also, the last part here, change direction, so it might turn, it might go left or right or up or down. Any of these changes to the motion are called examples of acceleration, okay? So with that too, if we keep that in mind, I'm going to go down to this part here, and we're going to talk about these examples we've got and talk about is acceleration happening here, yes or no? And then what kind of acceleration? Would it be speeding up? Would it be slowing down? Would it be changing direction? Okay, so in these examples we have a speed and we tell about what happens. So here we have a mouse. Let's think about mouse and whether the mouse would be accelerating. The mouse is going 1 meter per second as its speed, so 1 meter every second, and it's suddenly chased by a cat. So let's think, would the mouse accelerate in that case? Would its direction change? Not necessarily, maybe. But would its speed change? You better hope so, right? So hopefully that mouse is going to get moving and run, or else it's going to be part of a food chain, which it doesn't want to be, right? So here would say yes. We're going to make that red so we can see it better. We're going to say yes, acceleration happens. And what happens there is it speeds up, and maybe change direction too to try to get away, right? So speed up, change direction. Those are things that could happen in that case. So here would be an example where we do have acceleration happening, okay? Here we have another example. Our next one is a runner, and that runner is running 8 meters per second, so definitely faster than the mouse. And what happens is it runs at the same speed, so there's not a change in the speed here, and it goes around a circular track. So this example, we have to think about the direction. Does the direction change? It's on the track, but it would be turning as it goes around, curving around to the left or the right as it goes around that circular track. And this would be an example of changing motion or curved motion and changing direction. So this is, yes, we're going to say yes, this is acceleration. Acceleration happens here, and that's a change in direction. Okay, so the speed stays the same, but the velocity changes because that direction changes a little bit, okay? Now we have an example of a train, 80 kilometers per hour, which is a pretty quick train, and it moves along a straight track. So its speed is staying the same. If it's moving on a straight track, does that mean its direction changes, or does that stay the same? Well, it means that's going to stay the same too. So in this case, there's not a change in velocity, meaning the speed stays the same and the direction stays the same. So here there's not acceleration happening. So we're going to say no. Let's just say same velocity all throughout. Okay, great. Now the last one they give us here is we have a jet plane that's going 300 kilometers per hour, so the speed is staying the same. And oh, but no, it says yes, it slows down. So here we have an example of the jet slowing down. So what we need to do actually is tell what happened. So let's think about what could cause a jet to slow down. When might it be slowing down? If we're taking off, we go from not moving to going faster and faster and faster, maybe changing direction, maybe turning left and right as you go. When would a plane slow down? Well, it travels really fast when it's in the sky, but then it would slow down as it comes down for landing. So what I usually like to think of with this one is if we think about telling what would happen here, let's say plane approaches the runway, right? When it comes down for landing, it's got to slow down. Planes fly really, really fast to get us where we got to go in a quick way, but they have to slow down to be able to safely land, and that's where the acceleration happens in this case. Again, saying it slows down, the way we can match up a situation that we can say the plane approaches the runway to land and drop off passengers. Whatever it might be. Okay, so that's an example again of how we do have acceleration happening there. Here they tell us the acceleration happens and it slows down. Okay, so again, remember here, acceleration is any change in velocity, and velocity is speed or direction. So the speed could change by going faster or going slower. The direction could change by moving up or down, left or right, any direction like that. So again, if we say acceleration is a change in velocity, there's like two big factors with velocity: the speed and then also the direction. So lots of ways we can have acceleration happening. Okay, so that's a big thing for the day. The other part I wanted to look at today is actually in the brain check. Now, I'm not giving you the brain check to do like kind of regular homework because I kind of want to get through this a little quicker for us and focus on the big things. Okay, so what we were talking about yesterday was speed. This is page 251 of the brain check page. Now, you don't have the brain check as an assignment to complete, but I would like to go through this part with you here. And tomorrow what you'll have is the quiz. I made a little quiz online that you can follow along with. It's got same basic stuff as a normal quiz, vocab, multiple choice, and you just use your book to help you with that. But let's talk about how we can calculate speed to go back over that, because this is a big important thing with that as well. Okay, so with speed, we're talking about, again, distance divided by time is how we can find the speed of an object here. Okay, so here we have an example of a cow going through a pasture, I think, or a field, and we're going to answer the question. Now, it's asked, is the cow accelerating? Why or why not? What I actually want to do is talk about part B, is to calculate the speed first, and then we'll talk about whether that tells us that the cow is accelerating. Okay, one thing they tell us is the cow is going in a straight line across the field. So what does that tell us about, again, acceleration would be velocity changing, but if the cow is going in a straight line, that means it does not change direction. So in that case, acceleration is not happening. Now let's talk about the speed though. Now remember yesterday we talked about speed is distance divided by time is how we can find that. So here we have an amount of time up above, and the distance that cow has traveled in that amount of time. Okay, when it's standing still, it has no speed. We might say, again, distance divided by time. We're going to take the distance divided by the time here, and we're going to say 0 divided by 0 seconds would of course be 0, so no speed there. But if we talk about the speed at each step of the way here, let's go ahead and do that. Okay, if we're going to calculate the speed each step of the way, we're going to take, for each point we're at, the distance divided by the time. So we take the bottom number and then divide it by the top seconds of how much time has gone by, and that's how we can calculate our speed here. Okay, so let's take a look. For this first part, let me see if I'll make it a darker color and maybe make them a little bigger. Let's talk about what kind of speed we got. If we have 2 meters in 1 second, here we would say, okay, let's do 2 for the distance divided by 1 for the time, and we can just think, well, I know what 2 divided by 1 is, that's 2. So the speed in this case would be 2, and I'm going to put MPS for meters per second, okay? Meters per second in this case, again, whatever distance, in this case meters, divided by whatever time, in this case seconds, that's going to be 2 meters per second. And I abbreviate it here just because a lot of times we'll see that. The next part will be 4 divided by 2. So if I go ahead and do that over here, if I say, okay, distance is 4, divided by the time is 2, that's also going to be what? 4 divided by 2 will tell us the speed at this point would be 2, okay? Then if we keep going through, 6 divided by 3 seconds would be a way to measure that speed then, would also be 2. 6 divided by 3 is 2. And what do you know this? 8 divided by 4, hey, that's also 2. And as we keep going, 10 divided by 5 seconds would be also 2. So the speed here is the same, and the direction is also the same. So we can tell, let's calculate the speed of the cow. Well, it's a constant 2 meters per second. And talk about why is the cow accelerating, why are we not? In this case, we would say, let me actually go ahead and get that out of there, get this whole draw or type into space. In this case, we would say, well, what do we have? We have a constant speed, the same speed in the same direction. Neither of those things change. And since we know that acceleration is a change in velocity, we don't have any velocity changing here. So we can say, is the cow accelerating? We can say, no, it is not accelerating. We can say the velocity, speed, and direction stays the same the whole time. The whole time it's walking through the field, it's going in the same direction. It tells us a straight line, and it's going to be in the same speed, because as we calculated, the speed is 2 meters per second the whole way. So there's no change in speed, and there's no change in direction. Okay, now let's get to these other parts. This one says, how long will it take the cow to travel 24 meters? That's where we need to take some of the things we know. The speed, again, the speed is the distance divided by the time. If I take this equation and put it into here, we can say, all right, if I know speed equals distance divided by time, here I said I already know that my speed is 2. So I can say the speed of 2 is equal to the distance. So the question is, how far would it be in 24 meters? So we're saying if our distance is 24, what would the time be? And that's what we need to find out. Okay, so if we're doing it in this way, we just have to make the math work. Okay, we're going to also still do the dividing to find our answer here. We just need to make it work. So 24 divided by something equals 2. So let's think about that. What would my time have to be if that was the case? How can I make it equal to? Again, we know what our speed is. We just have to make the time match up. So what would the time have to be? Well, 24 divided by what would equal 2? Think about your math facts. That would be 12, right? 12 is what the time would be, and then seconds is what our amount of time is, okay? So 12 seconds would have to be what that time is, okay? That's how we can, again, use, if we know the speed, we can find the distance and time by thinking about how can I make it work to equal the speed in this case, okay? And then the last part is, and this is where it gets a little tricky sometimes, how far will a cow travel in 35 seconds, okay? We're going to use the same information here. If we know the speed is the distance divided by the time, and we know that this, the cows, let's see, we're going to try to find the distance, right? We're going to take the distance here, try to find out what that distance would be. So if we know the distance, and now we do know the time, and we're going to say that time is 35 seconds. Now, this is where we got to think a little bit about how to handle these type of things. This is like called algebra, where we need to kind of think in reverse. Here what we're trying to find is the answer. We divide the number by 35. Okay, so we're not going to do 35 divided by 2 or anything like that. We're going to think what number divided by 35 is going to equal 2. Okay, so again, this is a little bit of a different challenge, but that's going to tell us our distance. So we try to find that out. Let's think. If I take a larger number and divide it by 35, I end up at 2. Now, the way to think about that and find it out sort of in reverse and use these skills called algebra would be to multiply the two numbers that we do see, and that'll help us kind of work backwards and find the answer we want. So if we take 35 times 2, you would find out that that's actually 70. And a way to check this, we can say 70 meters is how far it would go. If we do 70 divided by 35, we'd find out that that is equal to 2, which would be the speed. So again, in these cases, when we know the speed, we can use the other information and use our math skills to find out the other missing parts. Okay, so sometimes we'll calculate the speed, and sometimes we'll know the speed and figure out the other things that go along with it. Okay, so this speed stuff is a big part of the lesson we're getting into And thank you guys again for hanging out and listening to that. Again, you might want to rewatch this one. I know I kind of went quick through a few little bits, but this is a good one to talk about, okay? Tomorrow you've got the quiz for me. Again, check your email and find that link, and you'll just follow along with that and answer those questions. Use your book to help you out, and do a great job. Love you guys.